Earth, like the other planets in our solar system, formed from a giant cloud of gas and dust called a solar nebula. This cloud was mostly made up of hydrogen and helium, but also contained heavier elements that had been produced in earlier generations of stars. The solar nebula was disturbed, possibly by a nearby supernova explosion, causing it to collapse under its own gravity. As the nebula collapsed, it began to spin faster and flatten into a rotating disk. At the center of the disk, the sun began to form, while particles in the outer regions clumped together to form planets, moons, asteroids, and other small bodies. Over millions of years, dust and ice particles collided and stuck together, gradually forming larger and larger bodies through a process called accretion. Earth began as a molten mass, constantly bombarded by other debris in the solar system. This intense bombardment and the heat from the planet's own interior kept it in a molten state for much of its early history. During this time, differentiation occurred. Denser materials, like iron and nickel, sank toward the center of the planet, forming the core, while lighter materials formed the mantle and crust. This process is crucial because it created the distinct layers of Earth, such as the solid inner core, the liquid outer core, the mantle, and the crust. The Earth began to cool, and solid landmasses began to form. Around 4.5 billion years ago, a Mars-sized body, often called Theia, collided with the young Earth, sending debris into orbit around the planet. This debris eventually coalesced to form the Moon. This collision had a significant impact on Earth, not only creating the Moon but also stabilizing the tilt of Earth's axis, which has influenced the planet's climate and seasons ever since. As Earth cooled, volcanic activity released gases including water vapor, carbon dioxide, nitrogen, and trace gases, forming the early atmosphere. Water vapor eventually condensed to form the first oceans, which covered the surface of the planet. These early oceans were vital because they provided the liquid water necessary for life to emerge. Life is believed to have originated around 3.5 to 4 billion years ago in the oceans. The exact process is still debated, but it likely involved simple molecules forming more complex structures through chemical reactions in the presence of energy sources like lightning or underwater volcanic vents. The earliest forms of life were microbial organisms, and over time these organisms evolved into more complex forms, eventually giving rise to plants, animals, and humans. Earth is located in what scientists call the habitable zone or Goldilocks zone of our solar system, where conditions are just right for life. This is the region where temperatures are not too hot and not too cold, allowing liquid water to exist on the planet's surface. If Earth were closer to the sun, water would evaporate, and if it were farther away, water would freeze. This narrow range of distance from a star is crucial for life to thrive. Earth has a relatively stable climate, which is regulated by the greenhouse effect. The atmosphere traps heat, keeping the surface temperature warm enough to support liquid water. Additionally, Earth has natural mechanisms that regulate the climate, such as ocean currents, volcanic activity, and plate tectonics. These systems help maintain long-term climate stability, which is essential for the development of complex life. Water is an essential ingredient for life. Earth is unique in the solar system for having abundant liquid water on its surface. Water is a solvent that facilitates the biochemical reactions necessary for life. It also helps regulate temperature and provides a medium for life to evolve and thrive. Earth's atmosphere is made up of nitrogen, oxygen, and trace gases like carbon dioxide and argon. This atmosphere serves as a protective shield, blocking harmful radiation from the sun and cosmic rays from outer space. It also helps regulate temperatures and supports life. Earth's atmosphere contains ozone, which absorbs and protects the planet from ultraviolet radiation, which would otherwise be lethal to most forms of life. Earth has a magnetic field generated by its iron-nickel core, which helps protect the planet from harmful solar winds and cosmic radiation. Without a magnetic field, the solar winds could strip away the atmosphere, as happened with Mars, which may have once had conditions favorable to life but lost its atmosphere due to the absence of a magnetic shield. Earth's plate tectonic system plays a crucial role in maintaining a stable climate and recycling important elements like carbon through the carbon cycle. Tectonic activity also contributes to the formation of landforms like mountains, oceans, and continents. It is believed that plate tectonics helped regulate the planet's temperature over millions of years, making Earth more hospitable to life. Earth continued to evolve through geological processes, including plate tectonics, erosion, and climate changes. Over billions of years, life on Earth became increasingly diverse, eventually leading to the complex ecosystems and species we see today, including humans. The entire process took billions of years, from the collapse of the solar nebula to the emergence of life and the world we know today. Earth's history is a dynamic and ongoing process with constant geological and atmospheric changes that continue to shape the planet.